target, I can calculate a function's average rate of change over a specified interval given the equation of a function. So you may have already looked at the video where you find the average rate of change given a table of values or over a graph. Today we're going to look specifically at how to find it just given the equation. On the OC, you're going to be given this as your definition for average rate of change, the change in the y value divided by the change in the x value for two distinct points on a graph. Some keywords here, when they talk about the change in y's and the change in x's, simply what we're doing here is subtracting. So we're subtracting our y's and we're subtracting our x's. So if I were to write a formula, it would look something like this: y2 minus y1 all over x2 minus x1, because I'm dividing those. This is very similar to what we do. It's actually the same formula that we use for slope, but slope is a constant rate of change. For parabolas and other types of functions, we're finding an average rate of change. So let's take a look at our first example. So what is the average rate of change of the quadratic function from x equals -2 to x equals 4? If we're given this specific function, so f of x equals x squared plus 3x minus 2. So we need to figure out what our y values are when x is -2 and when x is equal to 4. That way we can actually then go and apply our formula for our average rate of change. So we're going to substitute in each of those values to find the corresponding f of x values, or our y values if you think about it as a coordinate. Okay, so you're given the -2 of your coordinate, you need to find the y. You're given the 4 of your coordinate, you need to find the y. That's what we're doing. So I'm going to start with my first point for x. So I'm evaluating at -2. So I plug in -2 everywhere that I see an x. So -2 squared plus 3 times -2 minus 2. When we go to simplify that, we end up with 4 minus 6 minus 2, and that simplifies to -4. Okay, so this would also mean that this point here, if I write it out, is -2, -4, or I could fill it in up here. I'm just finding that y value. Then I do the same thing for my second x value when x is 4. So f of 4 equals 4 squared plus 3 times 4 minus 2, and then we simplified. 4 squared is 16, 3 times 4 is 12, and then we have the minus 2, and when I evaluate that, I end up with 26. So my point here would be 4, 26. All right, so now we have to find the average rate of change. So remember, for average rate of change, we take our y's that we subtract from one another, and we divide by our x's subtracted from one another. So my y's, I've got 26 minus -4, and then my x's 4 minus -2. My double negatives in the middle are going to turn into a positive, so 26 plus 4 and 4 plus 2. That simplifies to 30 over 6, which is 5. So my average rate of change between those 2 points is 5. We're going to do one more example. If you'd like to pause and try and check this on your own, feel free. We want to know the average rate of change of the quadratic function. We're using the same x coordinate, so x is equal to -2 and x is equal to 4, but my function is different this time. This time I'm given a function that is in vertex form. So I have f of x equals -0.25 times the quantity of x minus 2 all squared plus 6. So we start out the same way. We want to substitute in our given values. So I'm substituting in the -2 to find my y value, and then I'm going to substitute in the 4 to find my y value for that coordinate. So when I start with the -2, I'd end up with -0.25 times the quantity of -2 minus 2 all squared plus 6. You could just type this all into your calculator in one step. If you want to kind of do it step by step, this would be your next step. After you've used your order of operations, or PEMDAS, you do what's inside the parentheses first. So -2 minus 2 gives me that -4. And then if you want to evaluate that in your calculator, you end up with 2 as our answer. So my first coordinate would be -2, 2. That was my y value when x was -2. We do the same thing again, but this time I do it for 4. So now I evaluate my function at 4. So it would look like this, -0.25 times the quantity of 4 minus 2 all squared plus 6. And 4 minus 2 in the parentheses there would just simplify to 2. And when I evaluate that expression in my calculator, I get 5. So my coordinate here is 4, 5. Now we can go ahead and find the average rate of change between those two coordinates. So remember, we take our y's and we subtract them from one another, and we take our x's and we subtract them from one another, and then we divide those two together. So I've got 5 minus 2 for my y values, and I've got 4 minus -2 for my x's. And then we just simplify our numerator and denominator. 5 minus 2 is 3. And then I'm going to have 4 plus 2 because two negatives make a positive. 3 over 6 simplifies to 1/2 or 0.5. So my average rate of change here is just 1/2, or if you use the decimal, 0.5. If you still need of finding the average rate of change given the equation, you can check out the Learning Target spreadsheet for additional resources, videos, and practice.